Hi there everyone, I'm currently teaching benzene at the moment, so I thought I'd make a quick video explaining the bonding in benzene. So this is otherwise known as the delocalized model, and benzene compounds, any compound containing one or more benzene ring, is often referred to as an arene or an aromatic. So anytime you see the words arene or aromatic, just know that it means there's a benzene ring in that compound. Before we dive in to explaining the bonding in these structures, let's start with a definition of a sigma and a pi bond. So firstly, a sigma bond is a type of covalent bond that's formed by direct overlap between two orbitals. So if these pens were orbitals, then this would be the direct overlap here, and this would be the sigma bond formed. And if we look at this structure, we've got 6 carbon atoms in a ring, and these grey lobes, these regions of electron density, these are the 3 sigma bonds that surround each carbon atom. So if we look at this carbon atom, we've got 1, 2, 3 sigma bonds around that carbon. And if we look at this one, we've got 1, 2, 3 sigma bonds, and so on. Then if we look at the definition of a pi bond, that's also a type of covalent bond, but this one is formed by sideways overlap between 2 p orbitals. And I've highlighted the difference between these two definitions. So in a sigma bond, we've got direct overlap between 2 orbitals, but in a pi bond, it's specifically p orbitals and it's sideways overlap. So if we look at this model again, we've got p orbitals on each carbon. So if we look at this carbon, that's 1 p orbital. This carbon, that's another p orbital. So the purple and the pink are the 2 lobes of 1 p orbital. You might be more familiar with p orbitals looking like this, but that's exactly the same thing as what is in this structure. So 1 p orbital, 1 p orbital. And we call this shape a dumbbell shape that consists of 2 lobes, one lobe here and the second one there. So anyway, these p orbitals, so imagine these are the 2 p orbitals on 2 carbon atoms next to each other. They overlap to form a region of electron density above and below that ring. And this overlap between the p orbitals, which forms a pi system, forms this structure here, and this is known as the delocalized ring of pi electrons. So to summarize, each carbon atom has 4 outer shell electrons. 3 of those electrons are used to form a sigma bond. So we've got 1, 2, 3 electrons in 3 sigma bonds, and that 4th electron is sat in a p orbital. Adjacent, side by side, p orbitals overlap, and we end up with this delocalized pi system, and these p electrons are now free to move over the whole ring. So delocalized means that those electrons aren't fixed in place. They're now free to move around the ring. So that was just a short video describing the structure and bonding in the delocalized model of benzene. Hopefully that was helpful. If you need anything else, pop a message down in the comments below. Thank you for watching.